Finally, if you look at the formula for our arc length, L equals theta times r, and also the version where we divided both sides by delta t, then on the right side we had theta over delta t, which is in radians per second. That is our angular velocity that measures how fast something rotates. However, if you multiply it by r, then you will get L over delta t, which is length per unit time. And now that is in meters per second. This is already translational velocity. It shows you how fast the tip of the radius covers ground in a certain direction. It's the velocity that you also had when you had the car example. You can see that you can get it by looking at the units. Theta over delta t times r is radians per second times meters equals radians times meters over second equals meters over second. Because radians is meters over meters, it is dimensionless. And so, when we have circular rotation, which means that the length of the radius is constant, then in that case, the velocity of the tip of the radius is always tangent to the circumference and perpendicular to the radius. Furthermore, if the angular velocity is constant, so you are not spinning faster nor slower, but you are spinning at a constant rate, then the magnitude of the velocity of the radius tip will also be constant. It will change in direction all the time, because remember, it is always tangent to the circumference and perpendicular to the radius, but the magnitude of the velocity, the value of meters per second, will not change. So if a wind turbine rotates at a constant rate of 0.5 radians per second and the length of the blade is 30 meters, then the tip of the blade travels at 0.5 times 30 equals 15 meters per second. Its velocity is always perpendicular to the blade. In rotations, you also have to consider directions. In 2D, the general convention is that if something rotates at, let's say, 2 radians per second counterclockwise, then it is plus 2 radians per second. But if it rotates 2 radians per second clockwise, then it is minus 2 radians per second. In the next video, you will be taken back to the game world where you can get some practice. Good luck!